We often picture our cosmic neighborhood exactly like this old celestial map, a neat, flat disk where the planets sit perfectly aligned in their unchanging orbits. But the reality is far more violent. About 4.6 billion years ago, there was no map, just a massive, chaotic cloud of gas and dust. Gravity pulled this debris together, spinning it into a dense, rapidly collapsing vortex. At the center of that vortex, the pressure grew so intense that hydrogen atoms began smashing together. This massive collision triggered a nuclear fusion reaction, igniting the immense engine that drives our entire system, the Sun. To understand the sheer scale of this star, picture our home planet. You could fit approximately 1.3 million Earths inside the Sun's immense volume. And it dominates in weight, too. This star holds 99.8% of all the mass in our solar neighborhood. That means every rocky planet, massive gas giant, global ocean, and icy comet you know was constructed from a microscopic 0.2% of leftover cosmic dust. As we travel outward from this central star, that tiny fraction of leftovers creates worlds of bizarre, violent extremes. The worlds closest to the Sun take the brutal brunt of its heat. Mercury sits nearest to the fire. It is the smallest planet in the system, and because it has almost no atmosphere to trap warmth, temperatures that boil during the day plunge to solid freezing the moment the Sun sets. Step one planet further out to Venus, and the environment gets even hotter. Venus is wrapped in incredibly thick clouds that create a runaway greenhouse effect, permanently locking in the Sun's energy. The surface temperatures here stay high enough to melt solid lead. Only when we reach the third rock from the Sun do we find a balance. Earth's atmosphere filters harmful radiation while keeping conditions stable enough for liquid water to cover 71% of the surface, allowing life to thrive. Just past Earth sits Mars, covered in a fine layer of iron oxide, or rust, giving it a signature red glow. This desolate world is home to Olympus Mons, a dormant peak that stands as the single largest volcano in the entire solar system. Looking at this dry expanse, you wouldn't guess liquid water once flowed here. Today, landers scour this terrain for signs of ancient life. Beyond Mars, the rocky planets abruptly stop. We hit a massive debris field called the asteroid belt, packed with millions of leftover rocks and even a hidden dwarf planet named Ceres. In this inner neighborhood, a planet's fate depends entirely on its atmosphere. Whether a frozen rock, a toxic furnace, or an oasis for life, it comes down to that thin layer of protective gas. Crossing the asteroid debris field, the solid ground vanishes. We enter the realm of the gas giants, massive spheres composed almost entirely of hydrogen and helium gas. First is Jupiter, the undisputed heavyweight of the planets. It spins so violently that a full day lasts only 10 hours, whipping its atmosphere into huge storms. That includes the Great Red Spot, a massive hurricane churning for hundreds of years. Looking at this gravity map, we can see exactly how Jupiter's massive bulk acts as a cosmic vacuum cleaner. Its intense gravitational pull bends the flight paths of rogue comets and asteroids, deflecting them away from the fragile inner planets. Further out lies Saturn, the second largest planet, defined by a stunningly complex ring system built from millions of individual ice and rock particles. Despite its immense size, Saturn is highly diffuse. If you could find an ocean large enough, the entire planet would float. It also commands a vast collection of moons, including Titan, which features an active weather system where liquid methane rains from the sky. These massive gas worlds operate as secondary power brokers in our system. They dictate the movement of debris, protect the inner worlds from heavy impacts, and rule over dozens of highly active moons. Pushing even deeper into the dark, temperatures plummet. Here we find the ice giants, Uranus and Neptune. Notice how the spin of these planets compares. While Earth rotates on a slight tilt, Uranus rolls through space completely on its side, spinning on a 90-degree horizontal axis. Out past Uranus is Neptune. It owes its deep blue color to a thick atmosphere of methane gas, which gets whipped around by the fastest, most violent winds in the entire solar system. The immense distance from the Sun makes Neptune's orbit incredibly long. It takes 165 Earth years for the planet to complete a single trip around our star. Immense distance from the Sun defines the physics of these worlds. Out here, orbital years stretch across centuries, and weather is whipped into supersonic winds that look nothing like the storms of the inner system. Beyond Neptune, we hit the Kuiper Belt, a massive ring of frozen debris. This icy fringe is the domain of dwarf planets like Pluto, famous for its distinct heart-shaped glacier. Even further out lies the Oort cloud, a theoretical sphere of ice and rock that completely surrounds our solar system. Scientists believe this frozen shell is the birthplace of long-period comets. For most of their existence, these comets are just dark, drifting lumps of ice. They only develop this bright, glowing head and massive trailing tail when their orbit brings them close enough to the Sun to melt the ice into gas and dust. Humans have managed to send our own hardware out into this freezing borderland. The Voyager 1 probe, equipped with its large communication antenna and golden record of Earth sounds, is currently the farthest human-made object from our home planet. And as our automated probes push outward, we build increasingly massive tools down here on Earth to look deeper into the dark. Through these lenses, we are beginning to realize that the universe likely holds billions of systems similar to our own. Our 4.6 billion-year-old solar system is a single point of light on a much larger map. Exploring these 8 worlds is how we begin to find our coordinates among the billions of other stars scattered across